Hello, everybody. We're going to get started here on this webinar about Caravan, a new open source tool released by Unchained Capital. We are going to be recording the webinar. I just wanted to share that with all the participants. And let me get ahead and get started. My name is Dhruv Bansal. I work at Unchained Capital. I'm one of the co-founders and our chief science officer. Unchained Capital is a company which provides financial services to help long-term holders of Bitcoin better protect and manage their wealth. We've long been innovating in the area of multi-sig. We use multi-sig to deliver our financial services. That's one of the unique aspects of working with Unchained Capital. When you borrow with us using our collateralized Bitcoin loan product, or when you use our customer-controlled vaults, your keys, your public keys, are what we use to build multi-signature addresses. And then when we have to move funds, you participate in signing those transactions. It's something we call collaborative custody. We've been doing this for a while, and we've had a lot of success with customers, but we always felt that multi-sig shouldn't have required all the infrastructure we built. And so we wanted to release an open source tool that really helped anybody in the world do multi-sig quickly, easily, cheaply, and anonymously, as well as serve as a showcase for some of our learnings and to start a discourse with the community around how to do multi-sig better. So what I'll be showing off today is a couple of related projects. The first is called Caravan. That's the main title and the main project for this webinar. It's what we're calling a stateless multi-sig wallet or coordinator. You can think of it like an Electrum alternative for those who are looking for a simple tool to do multi-sig with. I'll also be talking after I demo Caravan about two open source libraries that Caravan uses and that we've also released. One is called Unchained Bitcoin and the other is called Unchained Wallets. They're both JavaScript libraries that we're hoping that other application developers can use to interact with some of the same kinds of devices that you'll see Caravan interacting with and do some of the same kinds of things. The audiences for Caravan and for this webinar are a number of different ones. So starting with developers, especially when I talk about libraries, it really is our intention to start a dialogue about the best practices for multi-sig development, patterns, standards, interoperability. And some of that was a little bit absent, we felt, in the ecosystem. And so we decided to release these projects to kind of fill that gap. Obviously, we want Bitcoiners out there who are excited about multi-sig for their own funds to be able to have a simple, easy to use, safe tool to do it. So we're excited just to speak with anybody out there who's got Bitcoin and is interested in using Caravan. Caravan talks to several what we would call sources of keys. And I'll get into that here in a minute. And so we're the folks who make keys, the wallet makers like Trezor, Ledger, Coldcard, et cetera, we want to drive them as a group towards standards to support greater interoperability and better security for all their users. Not all devices are created equal. Some do a great job in certain areas, others do a great job in other areas. We'd like to take the best learnings and try to make them standards so that everyone can follow them. And then it's definitely fair to say that Unchained is also a big audience for these projects. By releasing open source code, we hope to drive our internal development a little faster, as well as create open source, free, easy tools for our own customers to use for recovery purposes from our products. So before I get into demoing Caravan, I wanted to make just a brief mention of some of our design goals. We view Caravan as a sort of a member of a second generation in Bitcoin wallet software. In the first generation of what we would call a wallet, pictured there on the left, there's at least a few things going on at the same time. The wallet is, of course, what you interact with. It's your user interface to your Bitcoin assets. And you're looking at your balances, you're drafting transactions, you're signing them perhaps, at least if you're managing your own keys in your own wallet. But in order to do that, your wallet has to be able to deal with keys, and it has to be able to know what's happening on the blockchain. So it needs a source of consensus. The very first Bitcoin wallet that existed was the Bitcoin Core software, and of course did all of these three things, in addition to mining Bitcoin as well. And old wallets that have been around for a long time that are trusted and secure, like Electrum, they also have the same structure. They do all these things. Electrum has Electrum server, so you can literally get your consensus from the Electrum network. Like Electrum can store even a software key for you, as well as, of course, interact with keys elsewhere, and it coordinates all your transactions. From that perspective, Electrum is a very broad wallet, and that's, I'm not criticizing it for being that way. Electrum is reliably one of the first wallets to implement new features. It's been reliable for a long number of years, and we're all thankful for it being out there, but it does do a lot. And in the second generation of wallet software, what we think is happening is we see some lines emerging where software can be a little bit more modular and only do part of the job of what a first generation wallet like Bitcoin Core or Electrum could do. So Caravan is an example of that second generation of wallet software. It doesn't handle consensus. You have to plug it into a source of consensus. By default, we'll use blockstream.info, but you're free to use your own full node. Similarly, Caravan doesn't manage keys. You can't put a software private key into Caravan or wallet words or anything like that. It always talks to something else that manages your keys. That could be your hardware wallet. It could be another software application like Electrum. It could be any wallet at all, as long as it's capable of exporting public keys and signatures as text. So Caravan is really the coordinator between those external sources of state. And it doesn't really have any state itself. That's why we refer to it as a stateless multi-sig coordinator. So it's probably time to get into the actual demo of Caravan. Let me start by just pointing you at the GitHub page. Oh, the URL is a bit funny. There we go. I'm not sure. Well, that's strange URLs there. Okay, sorry. So Caravan is an open source library that Unchained released on our GitHub page. You can check us out at github.com/unchained-capital/caravan. It's an open source React web application. Anybody can run it, anybody can modify it. One of the easiest ways to get started using Caravan, in my view, is, well, you can use the URL that I'm going to be using here in a second. That's Unchained's hosted copy here on GitHub. But anybody with a GitHub account, even a free one, can fork this project. And the second you fork it, you will get a copy of this Caravan web application that GitHub hosts for you. The URL, instead of having Unchained Capital, will just have your GitHub username up here. That's a super quick one-click way to get your own copy of Caravan running for you. And it's yours now. If Unchained were to disappear, or if our GitHub page were to go down, your copy will survive and you can keep using this tool. So let me actually get into, there's actually a couple of really useful links here I'll maybe mention briefly. Well, of course, going back to the source code, we've also got some video tutorials on YouTube that walk you through doing a lot of what I'm doing today. And also a pretty informative blog post that talks a little bit more in depth about some of our goals with Caravan and what we hope to achieve. I'm going to do two things today in this demo. I'm going to first create a multi-signature address using a couple hardware wallets and an external wallet. And then I'm going to spend from a multi-sig address, just create a Bitcoin transaction and sign it using those same keys. So before we get started, let me click on the create button here and start the process of creating the address. But before we get started, let me point out that Caravan is a little bit different than some other wallets that you may have used. That right now, at least, Caravan only supports one multi-signature address at a time. So if you're going to use it, it's really more useful for if you're hodling for a long while. You can create the address, put your funds there, leave it, and then if you need to do a big transaction, you come back and you can spend from it. We do plan to release a multi-address version of Caravan soon. That would be more useful for folks who transact frequently and need to manage a whole bunch of addresses at once. But right now, I'm going to focus on just the one address at a time interface. This interface also, as you'll see, allows for a lot of flexibility and lets you explore a little bit how multisig even works. So I find that to be kind of interesting. So let me just right away, I have some interactivity here, and a few times during this creation process, mess with some of these settings, and we'll see the effects that they have. Most particularly, I can choose how many keys and how many are required to sign in the multi-sig address that I'm about to build. Default here is 2 of 3, but I can easily change the number of required signers up to the maximum number of signers. I can add signers that are required, and I'll just require more public keys over here in the next phase, or I can reduce them as well. So let's just stick with 2 of 3 for now. The next step is I need to start importing some public keys. So let me go ahead and I'll use a Trezor for right now. So let me go ahead and plug in this Trezor over here. And I need to choose a BIP32 path. This is one of the aspects of multi-sig that's challenging is the management of the state around BIP32 paths and how they're connected and how they're managed. There are some conventions that a lot of wallets follow. A lot of wallets don't follow those conventions. You'll see as I change the address type over here, which I'll do again later on as well, that BIP32 path changes based on some conventions and standards that Caravan tries to follow. Similarly, if I change the network from mainnet to testnet, I'll see that second component of the BIP32 path up there also change. So I'm going to work on testnet today, and let's go ahead and stick with a P to SH address. So I'm going to need to choose a BIP32 path here. I've prepared an address in advance that I want to use for this demo. So I'm going to use the BIP32 path of that address. Let me go ahead and by editing it, I can always change it and go back to the default if I think I've made a mistake. I'll go ahead and plug that in. So I'm going to go ahead and, yep, my Trezor is already plugged in. I'm going to go ahead and import from it. And go ahead and click allow, and I'm going to be exporting from testnet account 1002. That's fine. I've got to put in my PIN. So this is a testnet wallet only, so my PIN is very simple. I think if you're, of course, using real Bitcoin, you would want a real PIN. So immediately, as soon as I import the public key, there it is. That's literally what a public key looks like. This is the BIP32 path I had input, and it's just kind of stashed here. And I can move on and start adding additional public keys. Let me go ahead, and I'm going to use actually a second Trezor now to get the second public key. So I'll go ahead and plug that in. And there are several methods that I can use here. I can also use a Ledger hardware or wallet. I can use a Hermit. That's a open source command line only air-gapped wallet that Unchained Capital released. I can derive public keys from an extended public key for those who know about the difference between XPubs and regular public keys. And I can also enter a public key as text, which I'll be doing here in a minute. So let me go ahead and I'll grab a second BIP32 path here. I'll want to use a different one. I think, there we go. Let's use this guy. I'm just going to import that second public key. It's a very similar process. I may have to enter my PIN for the second device here. Again, it's a very simple PIN, but you should use a real one. And so there's that second public key. And notice I still don't have my address built down here because I'm only imported 2 out of the 3 public keys that are required. As soon as I add the third one, Caravan will build out that address for me. For the third key, let's argue that maybe I'm using an external wallet. It could be on an air-gapped computing device. It could be a custom piece of software or something like Bitcoin. I'm going to say that I've already exported a public key from that device in some way, and I can just enter it literally here just as text. Go ahead and paste that in, and now I've got a third public key, and I've got an address created. Now I get a warning right away that the public keys in the order that I've put them in, let me go ahead and label these just so that it's clear to me what's going on with the order. This was my Trezor A, this was my Trezor B. Oh, come on, can't type today, there we go. And this was my external wallet. I'll call this my air-gapped. So I can give those keys labels, that'll help me to remember them here, but they're not in the correct order. So this is another example of a standard that Caravan tries to support. There's something called BIP67, which just describes a standard for ordering keys when we're building multi-signature addresses. I can easily put the keys into the correct order as expected by that standard, and so now they get shifted around. Looks like the air-gapped key needed to come first. And so that's cool, Caravan helps me be on standard, but if I need to reorder the keys, if I decide that I want to somehow be in the wrong order, I can't. That flexibility is useful because historically not every wallet has used or conformed to the BIP67 standard. And so it's helpful for if you're a developer or someone trying to do recovery that you can sort of violate that standard, but at least you get a warning about it. So I'll go ahead and stick to the standard, and we'll stick in the right order. And let's take a look a little bit more at what Caravan shows me here. So this is a 2 of 3 multi-sig P to SH address. It's Bitcoin, it's testnet. I can see the script, both in hexadecimal representation as well as in actual opcodes. And the most important part about this is the redeem script. Let me go ahead and download these address details, and I'll get a file here. All this information that I'll need in order to later on use and spend from this address is in this file that we've downloaded here. So I've got the address, the network type, what kind of quorum it is. I've got the keys as I labeled them, along with the BIP32 pass that I used to derive them. And I've got the redeem script. Notice that Caravan doesn't know the BIP32 path for the key that I entered from my external wallet. That's important too. Not every wallet is an HD wallet. So it's possible that I could be using a device that just is capable of exporting a single public key, and Caravan can work with that situation. So if I want to use this address, I will later on need this redeem script and knowledge of these public keys. So it's important to keep this file somewhere safe. This information cannot be used to directly spend your Bitcoin, at least not with today's computing devices, but it's important to keep it secret nonetheless. With that said, I can actually change this address here on the fly. Like for example, if I decided I wanted to make this a P2 WSH, a native SegWit address, I could click that button and notice that the address is totally different. Now I'm getting some warnings here. Those warnings are again Caravan letting me know that the paths which I chose aren't really the standard for native SegWit paths if I'm building multi-sig addresses. And so I might, want to be careful and, proceed only if I know what I'm doing, but maybe I do know exactly what I'm doing because I'm trying to recover from a wallet that works this way. I can actually also even switch from mainnet to testnet. I'll continue to get similar warnings because again, I'm using some strange paths, at least as far as Caravan is concerned, but this is a valid address and I can use this. And historically, some wallet somewhere might have. So it's nice to be able to violate those standards again, while being at least warned that you're doing them. So let's go back to something that's safe. So P to SH testnet. Okay, cool. So I've created that address here. The next step would be I could send Bitcoin to this address. I could, it's cold storage, so I don't have to have Caravan. I don't need to use it. I just need to pass that address around and I can fund it from anywhere. I need to keep safe the Trezors, or if I used a ledger or whatever wallets I'm using, I need to make sure these hardware wallets are kept safe. I need to make sure the backup seeds are kept safe. But other than that, I'm ready to go. I can use this address. I just imported my public keys from a couple different Trezors and from an air-gapped external device. And Caravan has created for me now the address that this corresponds to. The important part is that these same public keys can correspond to many different addresses depending on the other settings that I've chosen. And I can change them on the fly and Caravan will respond by changing that address. So for example, I can go from a P to SH address type to a P to WSH address type. The address changes and I get a native SegWit address here, but I will get a warning from Caravan letting me know that my prior choice of BIP32 pass is a little bit non-standard. Again, Caravan really supports this idea of encouraging you to be on the standard, but if you need to violate a standard because you're trying to recover from some wallet that doesn't respect it, you can do that as well. I can even switch from testnet to mainnet, and I can even, for example, change the number of required signers, and I'll get yet another different address. For those who follow Bitcoin script, you can see that op2 turned into an op1, indicating that I have one required signer now instead of 2. All this information will be in the file that you download. And when you want to spend from this address, you're going to need the information in that file. And to be clear, the information in that file is not your private keys. Your private keys are on your Trezors, or they're on the air-gapped wallet that you're using externally. But this information should still be kept secret. It can be used to, in some cases, de-anonymize you if you don't want that to be possible. And it's just considered a best practice not to reveal your redeem scripts for addresses that still contain funds. So moving on to the next step, and let's say I've actually gone ahead and I was using the 2 of 3 P to SH testnet address. And so now the warnings go away. And I've created this address already. I showed on a block, this link takes me to a block explorer, and there is already about 0.01 testnet Bitcoin in there. So now my goal is I want to spend that Bitcoin that I had previously accumulated in this multi-sig address. So I've already got the keys with me, but the first step, and maybe I'll just start this step over. I need to enter that same redeem script. This is the information that Caravan was displaying for me right here, and that is contained in the file that I downloaded. So let me go ahead and copy it, stash it in here. And just as before, that redeem script corresponds to several different addresses depending on how I choose to interpret it. In this case, I want to stick with P to SH, but I want to choose a testnet address because we're working on testnet today. The next step, Caravan, I can confirm. I have a couple options here. I can either just choose to confirm that I own this address. That's very useful if I've got a Trezor or I've got some wallet and I just want to double check. Look, is this hardware device controlling the funds in this address? So that's a useful side thing that a person can do. Alternatively, what I want to do right now is I actually want to spend real funds. So I'm going to move funds from this address, the 0.01 Bitcoin that's in there. At this point, in order to actually take this step, Caravan needs to look up what funds are in this address. And it's not just because we need to account for it and show you that, hey, there's 0.01 Bitcoin in there. It's because from a technical perspective, Caravan needs a list of the UTXOs that you intend to spend. For this is a great example of where we're reaching out to pull consensus. Previously, when we were creating an address, we didn't really need to know the state of the Bitcoin network, but in this case, we do. By default, Caravan is going to pull this consensus information, the balances and the UTXOs, from the blockstream.info API. But I'm free to go ahead and just use my own Bitcoin node if I'd like. There are a couple steps of preparation here. I might need to set up a CORS proxy, and I certainly will have to put any addresses that I intend to interact with into my Bitcoin node's watch list. So it's watching those addresses and tracking their UTXOs. But if I don't want to use blockstream.info, I'm free not to do so. For today's demo, I'm just going to stick to using blockstream.info because they automatically track all addresses, and that's really convenient. So let me go ahead and spend from this address. So as I said, the first step is Caravan will go look up, here are the UTXOs that are available. There's a total of 0.01 Bitcoin available. And now I can go ahead and author a transaction spending some of those funds. So the first thing I'm going to need is an address to send my funds to. I've got one prepared over here. Let me go ahead and grab it. This is just another testnet address. It's actually the testnet address of a faucet. So I'm just going to send some Bitcoin back to where I originally got it from. And I can go ahead now and I can add various outputs if I'd like and further, places to send Bitcoin. I'm just going to, for now, have one output. The fee rate is automatically estimated by querying the blockstream.info or your Bitcoin node. I can mess with that and change it if I'd like to. I can automatically then balance the transaction so that fees, total outputs and fees matches total inputs. So now that I'm happy with the transaction, let me go ahead and let's gather the signatures that I need to actually authorize it and then get it broadcast to the Bitcoin network. So I had used previously 2 Trezors and an external wallet. I need to have those devices available or be able to get signatures from them in order to move these funds. I'm going to choose to use one of those Trezors and my external wallet, which I've actually already exported a signature from. Actually, you know what? Oh, I'm sorry. I think I used a different fee. So let me go ahead and just use my Trezor again twice. So let me go ahead and grab the BIP32 pass that I need here. Oops. Just having trouble with my keyboard. So the first step I'm going to do is actually verify that the wallet I've got plugged in is indeed participating in this address. So let me go ahead and click verify. I'm talking to Trezor Connect here. I'm going to go ahead and just export a key. I have to put in my PIN just as I did before. And I should be the same thing. Yep, there we go. So this is verified and I can sign now. So I know that this, let me go ahead and label this guy. This is Trezor A. It's the first one I used. So I know that Trezor A is actually correctly in this quorum. I can go ahead and sign. I'm going to get a bunch of instructions and a dialog from Trezor Connect. And now if you've ever used a Trezor, you know my screen is showing me exactly this information, and it's asking me to confirm each of these steps. Hey, do I really want to send funds to this address? Let me confirm the address. Yes, that looks correct to me. And is that the correct fee and the correct total amount? Yes, it is. So let me go ahead and boom, I've got a signature there. So let me go ahead and export a second signature. I'll do this maybe from my second Trezor. So let me unplug the one I've got in and plug in the second one. Let me go ahead and also put in the, that's a second Trezor, put in the path that I want to use. That's the path that I got. I can get that from the file that I downloaded. Let me go ahead and verify this, exactly the same steps as before. I've got to re-put in the PIN because this is a different device. I just unplugged and replugged it. So there we go. Sign this. And it's the same information. I'm just repeating this step so we can get that second signature. And again, I need to go back and confirm that I've got the correct information. So is that the right address? It is indeed. Confirm that and confirm the fees and the total amount, and I should get a second signature. As soon as I got a second signature, I can go ahead and take this transaction and broadcast it anytime I like. I can copy and paste it and take it somewhere else and broadcast it in case I'm running Caravan in an environment which doesn't have access to the internet. But let me go ahead and just directly broadcast it right now. So there we go, and that's the transaction ID that I've gotten. I can actually get a link and go check out the Block Explorer where now I'm actually spending this transaction. Now, we could have been cheaper had we used a native SegWit. And so next time, maybe I will pick P to WSH just to save overpaying a little bit. But at this point, I've managed to create the address and just in a few minutes, spend from it again using these devices. Let me flip back to my slides now. Sorry?
We want to take a moment for questions.
Yeah, actually, that's a great idea. At this point, my plan was just to get into some of the open source libraries and talk a little bit more about some of our design decisions. This is a great time to pause and get any questions from those who are online.
So we have two questions. Can you show how ledgers work today? And then also, can you talk about cold card and PSBT?
Great, let me take that second part first. Yeah, we can demo Ledger as well. I've actually shared, I can actually use, we'll demo Ledger here in just a second. Let's talk about cold card and PSBT. So one of the challenges of PSBT, it's a great standard that's come out now, but it is new. And unfortunately, not a lot of hardware devices support it. And I made this point previously here about wallet makers, driving them towards more interoperable standards. I think one of the great things about having cold card in the market today is that because they've embraced PSBT, which is a great standard for expressing and sharing Bitcoin transactions between devices, they're driving the whole industry forward. Today, Caravan does not use PSBT, chiefly because Caravan is not operating with, talking to a cold card yet. Trezors and ledgers and the other wallets and of course just direct text entry of signatures that Caravan supports, none of those systems use PSBT yet. I think what our plans would be here at Unchained, of course, as an open source project, anybody is free to change this anytime they like. But what we're thinking about for our roadmap is when we support cold card, which is something we'd very much like to do, at that point, we'll have to learn how to support PSBT within Caravan, and that'll be the right opportunity to use it as within Caravan. Until Trezor or Ledger, for example, start to support PSBT on their own, it'll be kind of a little bit of a weird thing where, okay, so Caravan is maybe using the PSBTs and then just having to turn, not passing them to the Trezor or Ledger, but just passing the appropriate data that they currently want as part of their own APIs. So that's the reason that we didn't implement PSBT right now, is because if we implemented it, we would just have to sort of undo our work when we talk to these devices. But once we have cold card, it'll be worth it, I think, to use that as a standard. Okay, so Ledger. Yeah, so I just didn't have a Ledger device on me here, but I've got one here. We just grabbed one from the office. So I can plug it in here. Let's take a quick look. So something that I can do is maybe I can quickly check whether this Ledger is a member of this quorum. Or maybe let's start by going back to the create screen and we'll actually just export a public key real fast. So that'll be a simple way to start with a Ledger, and then we can take a next step. Plug this guy in. Just a second. I've got to set up the Ledger and get it all logged in here. Just got to enter my PIN. Trezors, of course, or actually, let me go ahead and pick Ledger here since that's my intent here. Ledgers are a little bit different than Trezors, that we've got to kind of log in first as compared to after. So you can kind of see that I'm getting the instructions to make sure my Ledger is plugged in, that I unlocked it, and I need to open the Bitcoin app. So I'm kind of taking those steps right now, opening up my Bitcoin app, and now I'll be able to, oh my God, remind me tomorrow on Mac. So we got a Nano S plugged in here, and I'm going to go ahead and let's stick to the same thing. I can actually, we'll go to testnet, we'll import a public key. And so my Ledger is talking to me. I'm seeing on my screen the dialogue about the derivation path. So I'm saying, okay, go for it, and there we go. So that's just importing a public key directly from a Ledger. I actually think, correct me if I'm wrong, yeah, so I just confirmed. So this actually is the same wallet words as another device that we use. So we can actually export a very similar, we could have done the same transactions with this device. Let me go ahead and we'll maybe do a quick check where we can check the redeem script. Grab that. Since I've already broadcast from this P2SH address, I won't be able to spend from it again, but I should be able to check the ownership. Let me go ahead and pick a Ledger. So same thing, I've got to plug it in. Since I unplugged it, I've got to now go ahead and log in again. And let's grab the correct path. Stick that in here. And we're just finishing the login, opening up the Bitcoin app and importing the public key, getting the same dialogues on my screen. I'm clicking through them with the Ledger. There we go. So that's actually, there we go. So that's an example of not signing a transaction, but exporting a public key and confirming that we have, that this wallet is indeed a member of the quorum for this address. Do we have any other questions that are coming in from the webinar? Here's a question from Joe. The question is the path the same for any transactions made for the multi-sig wallet? So that's an interesting question. I think this is one of the challenges of multi-sig is that the paths are in general very different across different kinds of wallets and devices. A great site to refer to here is walletsrecovery.org. This is not just multi-sig sites. This includes a lot of single signature wallets, but it gives you a quick sense of the variation here. We're looking at BIP32 paths. So it gives you a quick sense of like the variation in people's choices of BIP32 path. And this is true in single signature, this is true in multi-signature. And what's nice about Caravan is Caravan also makes a set of choices. If we, for example, if I go pick a device here, it also makes some choices. On P2SH, we're going to use M45 prime. If we go to P2WSH, we're going to use M48.1. These are some standards that have emerged for these address types. And so Caravan encourages us to use these standards. And so in that sense, if you always use the standard recommended by Caravan, the BIP32 paths will always at least have the same prefix. They'll start out similarly. As you iterate, you'll want to use different last parts. For example, if I create multiple addresses, I'll want to increment this number and use multiple different public keys as I kind of go through and use different addresses. But if I want to, I can break all sorts of rules here. Again, that's why I'm getting some of these warnings, because Caravan is telling me, this is a little bit strange. I don't think that that's the standard. Are you sure you know what you're doing? Well, you may have to do something that's a little bit off standard if you're attempting to support some kind of multi-sig from some tool that just has its own behavior. So we'll keep taking questions, just kind of share them in the chat, but maybe for the remaining 15 minutes or so of time that we have here, I wanted to talk a little bit more about some of the libraries that are behind Caravan. So just flipping back to some of my slides here, the two libraries that are important are called Unchained Bitcoin and Unchained Wallets. Unchained Bitcoin right here is another open source GitHub library. It's a JavaScript library that's designed to just add a little bit of functionality on top of the excellent Bitcoin JS lib. So if you're a Bitcoin JS lib user in your application and you want to do a little bit more multi-sig stuff, this can be really helpful. In particular, some of the features that we added, let me go ahead and present this screen, make it a bit bigger. Some of the features some of the functions from Unchained Bitcoin are kind of displayed below. And I haven't shown the bodies, but you can imagine what these functions do. They're just simple utility functions that anybody who's worked with multisig or worked with hardware wallets or worked with external sources of signatures and stuff is going to need these functions. And they're just not implemented in Bitcoin JS lib, and they're not consistently implemented in other libraries. A great example is something like BIP32 path to sequence. It's traditional to represent BIP32 paths as strings, but for some reason the Trezor API really likes taking it as a sequence of integers. And that difference is a really trivial, immaterial difference, but it matters when you're programming. It's just nice to have a function that's written and tested that just does that correctly for you. Another great example is validation. There are out there a lot of libraries that have functions in them that look something like validate BIP32 path, but they're not sufficiently correct, nor are they sufficiently flexible for the purposes of truly using BIP32 paths in an interactive application. In particular, oftentimes it's just the shape of the path which is validated. Hey, does it start with M? Does it have slashes, numbers, and a few primes? That's okay if you're being loose, but we really need to be precise about our usage of BIP32 paths, because if you get your BIP32 paths wrong, you're not going to be able to sign for the funds. You're not going to be able to verify ownership. It'll be a mess. And so, for example, we validate things in this function. We validate the actual numbers themselves. Certain wallets have started to put in restrictions that you can't have BIP32 paths that are arbitrary values, that there are some numeric bounds. And so this is a way for wallet code to hook into that. There's also, for example, the requirement that sometimes you really want a fully hardened or a fully unhardened BIP32 path. And so those are the kinds of options that you can kind of add in. And so these are just sort of a collection of useful functions from this library. Another example of something that's kind of useful is, especially for multisig, using native Bitcoin JS lib gets a little wordy and a little too many functions and too many redeem scripts within redeem scripts. This is a particularly heinous example because this represents a P to SH wrapped SegWit transaction. So it's one of the more complex multisig transactions or addresses you could hope to build. But just sort of comparing the top and bottom version, you have to import a couple things in both. But in the Unchained Bitcoin library, we've wrapped this functionality to make it pretty easy for you to generate multi-sig addresses, even complex ones like these. So these are a couple quick examples of the kind of stuff that's in this Bitcoin utility library that we've created. I also want to show the second library we've built, which is Unchained Wallets. So also, these are all hosted out of the Unchained Capital GitHub. So Unchained Wallets is meant to be an abstraction layer across, it's another JavaScript library that's an abstraction layer across different hardware wallets and hopefully over time, many other kinds of wallets as well. I talked previously about cold card support. This is the library in which we would implement cold card support. We would add a module that implements the interfaces defined by this library and meets them with cold card. I'll come back to the interface design here in a second, but I wanted to just, oh no, here we go, right here. So coming back to the slides, the Unchained Wallets library basically works by defining this API structure. It's pretty simple. You have a JavaScript class. You can pass in parameters that matter for the wallet interaction you're dealing with, things like the network, as in this example, or BIP32 paths, or keys, or inputs, whatever it is that you're trying to wrap. There's a concept of a supported or not supported. There's a messages data structure, which returns messages for various possible states of the wallet. And there's a run method, which is the sort of concrete implementation, which actually talks to the wallet and extracts the data that you need from it, public keys, signatures, etc. I think one thing that's important to see about this API is that it's extremely functional. This class is designed to have no internal state. That's really handy and nice when you're dealing with JavaScript view libraries like React or Redux, which they really want to manage state on their own. And it's challenging to have to, for example, pass callbacks back and forth to coordinate state between those libraries and a wallet library. So it's really nice to have something that is sort of stateless into which you can pass your own state and extract the information that you need. We're really curious over time as we start to support more wallets and as the community starts to implement wallet support for Caravan by adding modules to Unchained wallets, whether this API is sufficient or whether it needs modifying. This is probably one of the areas where we're most uncertain of because we only have 2 or 3 examples where we're supporting something. As we have 5 and 10, we'll know a lot better, I think, what this API should evolve to look like. This is an area where we're extremely excited about feedback from the community, especially from wallet providers. This is supported function is pretty vital. One thing that we've learned at Unchained is that wallets, the interaction between wallets and browsers and operating systems is extremely brittle. That there's all sorts of edge cases in which a wallet simply won't work. And it's important to be able to detect that and give that kind of feedback back to the user. There's also, for example, certain combinations of arguments that don't work. If you're exporting a BIP32 path, for example, if you're exporting a public key from a Trezor device, it'll care about the second component of the BIP32 path, but the Ledger device will not. And so there are some constraints which depend on the parameters that you pass in as well. So is supported is a great way for the wallet library author to communicate to the application developer that the user's selected parameters don't make sense or unsupported. Another feature of the wallets library or of the API that we've designed that we think is really useful is the fact that the messages data structure that is produced by implementing library classes can be very rich. It's not just messages for text. Here in the simple example that we have here, this is literally just a message with a small amount of text in it. But this more complex example is a message that has several steps and has some maybe serialized image data. And what's exciting about that is it allows the application developers to build nice complex interfaces. For example, on the right-hand side is a screenshot, actually not from Caravan, but from Unchained Capital's private application that, using a ledger with complicated BIP32 paths can get really tricky. And so or ledgers give a warning that can be confusing to users when they're using BIP32 paths that they don't recognize. Those BIP32 paths are perfectly fine and safe and part of a standard, but they're just not one that ledger understands. And so you get this warning, and that can be unnerving for a user. So it's really nice when the user interface says, hey, look, this is going to happen. Your screen is going to look exactly like this. Press exactly these buttons exactly these many times, and you'll be fine. So it's hard work to build that interface, to know that you have this constraint, to take the little images and make sure they look correct and line them all up. That's difficult, and application developers don't always have the time to take that extra step, and that leads to confusion on behalf of users, which is bad for Bitcoin. So if wallet libraries think about that in advance, and as the Unchained Wallet library tries to do, surface to the application developer all the data they need to lay out a warning dialogue like the one on the right very beautifully, that's going to help usability across the board. So what our hope is that Unchained wallets can kind of solve those problems of warnings and edge cases for users of hardware wallets and other kinds of key stores so that application developers can deliver a uniformly better experience to their users. So do we have any more questions that we want to take from the audience?
Not at the moment, but we can open it up.
We'll give a minute for folks to share questions. Okay, great. We have one question coming in is about sort of more custom multi-sig options. Like, is it possible to build like if we go back to the create dialog here, is it possible to do something more complex than 2 of 3, or excuse me, M of N? So I showed before how, Caravan allows a pretty arbitrary combination of M and N here, so you kind of can do almost any multi-sig configuration you want. But can I do like M of N or some other constraint? Can I do M of N or after some number of blocks, revert back to the first key out of the three? So the answer today is no, that Caravan is very much just multi-sig, M of N. You can pick M and you can pick N, but that's, and you can of course pick all these parameters around your addresses, but that's about as complex as the quorum construction gets. Moving forward, an area that we're really excited about is better technology for wallets to describe exactly what kind of structure they create for their addresses. So are you a multi-sig M of N wallet? No, I'm not. I'm an M of N wallet with this extra constraint that after 1,000 blocks, each of my addresses reverts to this first key. So how do we express that idea cleanly? There's a couple of different alternatives. One is called miniscript. Another is called the descriptor framework. These are both areas that we're actively investigating to be able to try to use to, one, document what Caravan is doing, but also serve as a way for users to input instructions to Caravan. So perhaps instead of a series of dialogues and user interface widgets that help you add options like time locks, maybe a nice way to support arbitrary complexity here would be for users to be able to specify in either a descriptor framework or a miniscript a template for Caravan to then use as it builds out addresses on their behalf. Someone asked a question about if there are no more real questions, can we get cosmic for a bit and talk about brain candy you've been thinking about lately? Let's see. Well, I'll say one thing. I'll say one very brief thing. This is a little bit silly, but so I had a really nice happy hour yesterday with my old advisor from the graduate physics program here at the University of Texas at Austin, where I was previously a graduate student. He's an awesome and very forward-thinking and open-minded person, but he hasn't had a lot of exposure to Bitcoin. And so one of my sort of secret side missions over the last couple of years is periodically meeting with him and getting him excited about Bitcoin. And it's interesting because he's a professor of physics. He does not, I don't think, have a deep knowledge or maybe a huge exposure to ideas of sound money or Austrian economics or any of these sort of concepts. But he's of course a brilliant physicist. And so I think the angle that I've taken with speaking with him has been Bitcoin and how it relates to energy and how it relates to and how artificial scarcity is achieved. And so it's been cool. He's been picking up on it pretty fast. But yesterday we had a great conversation in which, on the spirit of getting cosmic, we're talking about treating Bitcoin, like taking it seriously, the idea that, hey, there's this machine and it, like the history of, some in the audience here are already going to laugh when I say this word, but the history of thermodynamics starts with thinking about engines and machines and efficiency. And, Bitcoin is a machine that is global in scale, that uses a huge amount of energy, and that we might be able to understand from perspective of its efficiencies and its thermodynamics. And that's an idea I've been toying with for a little while. If you read some of our prior articles on Bitcoin Dust, there's some thinking in there about these ideas. But the interesting part is that my old advisor got really excited about this and was like, oh, there's the excellent theorem of Caravan theory or whatever that relates very directly. And so I think I made a convert, and I'm really excited for what we may come up with in the future about that. So that's just a little bit of exciting personal news for me. Okay, I think that's it. No more cosmic space questions. Thank you all so much for attending this webinar. It was excellent fun to show you this open source tool that we've released. Again, it's open source, so I encourage you to go check it out. File GitHub issues for feature requests or bugs that you find. Feel free to contribute. Wallet makers out there, please give us feedback on the Unchained Wallets library, and if the API is sufficient to implement interfaces for your wallet. The more wallets that we can support, the richer and more useful Caravan becomes for everybody. All right, thanks everybody.
Thanks, Dhruv. Thanks, guys.